Hello, this is Scholar Strife. We're doing some math. Today we'll be looking at Algebra 2, Section 5.4, Factor and Solve Polynomial Equations. In the last chapter, in Chapter 4, we did a lot of factoring, and we've seen some of these techniques in here, but we're going to take a look at them again, because this time we're working with not just quadratics, but with cubics and quartics and whatever, polynomials. So here we go. Looking at the sum and difference of cubes. So these first two here, a cubed plus b cubed, that is equal to a plus b times the quantity a squared minus a b plus b squared. And then you can take a look at a cubed minus b cubed there. Very similar, but a minus b, and then that. So let's do an example problem. So the first thing you always got to do is factor out your common terms. So both of these I can take a 2 out of, just to start with, or maybe that's all I need. I'm going to take 2 out of both of them, and I'm also going to take a z squared out, because I have two z's. So 16 divided by 2 is 8, and then take away 2 z's, so that's z cubed, minus 250 divided by 2 is 125, and then there's no more z's there. Okay? And then look, it's become a cubed minus b cubed in this parentheses here. So remember, you always got to find out what a is and b is. So if a cubed is 8z cubed, then a is the cubed root of 8z cubed, which is 2z. So not only did I cube root 8, I cube root z cubed. So a is 2z. B, in this case, is just the cube root of 125, which is 5. 5 to the third power is 125. So let's continue on. So we know what A is, we know what B is. Now we can plug everything in to our second equation here, because this is an a cubed minus b cubed situation. So first off, I still have that 2z squared up in the front, and then we're going to do parentheses a minus b, so 2z minus b, so b is 5, times the quantity a squared, which is 4z squared, plus a times b, so a times b is 2z plus, or 2z times 5, which is a positive 10z, plus b squared, which is 25. And that's it. So for this next example, we're going to factor by grouping. Whatever you're grouping, you need at least, you always need an even number of terms in the polynomial. So that's what this chicken scratch says. So what that means is we have 1, 2, 3, 4 terms. That's an even number, so we can group it. So normally you split it in half. So if there was 6, you split it into 3 groups. You might not necessarily split it into 3, but for our example here, we just split it in half. So I got 4c cubed plus 8c squared, and I'm just going to look at that. And then we have minus 9c minus 18, and then I'm going to look at that. I'm not multiplying here. I'm just kind of separating them. Out of this first group, I'm going to pull out 4c squared. And I get c plus 2. And then over here, I'm going to pull out a negative 9. And get c plus 2. So notice that this is c plus 2, and that's c plus 2. That means we can do this. So this is the same thing as saying 4c squared apples minus 9c squared, or sorry, 4c squared apples minus 9 apples is the same thing as 4c squared minus 9 apples. They both share a c plus 2, so I can combine my 4c squared minus 9 and then multiply it by c plus 2. And then, even though it looks like we're done, we're still not done because we have a difference of squares here. So a squared minus b squared. So whenever we have that, that becomes the 2c plus 3, 2c minus 3. Let's see if I can erase. Yep. Whoa. Stop. 2c minus 3. And then c plus 2. Okay, so this first one was in the form a squared minus b squared, which hopefully you'll remember becomes a plus b, a minus b. And then, I believe that's it for that one. So for this next one, it's going to look like a quadratic formula, even though we're going to have higher exponents. But here, I'll show you how it goes. So all of these actually share a 2 and a p squared. So you always take that out first. So we have 2p squared p to the 6 plus 5p to the 3rd plus 6. Now we kind of want to... Basically, the inside here kind of looks like a quadratic form, where p to the 6 is the same thing as p to the cubed squared. Okay, so that would be, so my p to the 6 would kind of be like my x squared value in a quadratic, and then p to the cubed is my x, and then I still have my constant 6. So we're going to factor this just like any old quadratic. 2p squared. And then we have p to the cubed here, and a p to the cubed here. So we're looking for two values that multiply to 6 and add up to 5. And that is 3 and 2. Okay. And if you ever want to check, just remultiply it all out using your FOIL method. But this is as far as we can go. Alright, solving for roots. This is when we finally have an equal sign. So before we were just simplifying. Now we're going to do... Now we have an equal sign, so we're going to actually solve for roots. So the first thing you got to do is move everything to one side. I always like having the coefficient of my highest exponent positive. So my highest exponent here is 3x to the 5th. So I'm just going to move over 18x cubed to the other side by subtracting it. So I have 3x to the 5th minus 18x cubed plus 15x. Okay, first thing you got to do is take out anything you can. I can take out a 3 and an x. Knowing your multiplication tables is very valuable. X to the 4th minus 6x squared plus 5 equals 0. So, next, the inside here actually looks like a quadratic, where my x squared value, so my x to the 4th is actually my x squared value because it looks like x squared squared. Okay. So here we go. Just factoring it. 3x times x to the squared. And then we're going to have x squared here. Looking for two numbers that multiply to 5 and add up to -6. That would be -5 and -1. And then we set this equal to 0. So when we have our when our highest, so when you're looking for the number of answers that you should have, we look at our degree. So our degree here, or the highest exponent, is 5. So we have a possible 5 answers here. Okay, so let's look at the first one. First one is 3x equals 0, so x equals 0. Well, that was easy. And then we look at x squared minus 5 equals 0. So I move it over, I get x squared equals 5. Whoa. So that means if I put the square root over something, I get x equals plus or minus the square root of 5. So that's actually 2 answers. So I have 0, positive square root of 5, negative square root of 5. And then lastly, x squared minus 1 equals 0. So x squared equals 1. Take the square root. That means x equals plus or minus 1. So we have 5 answers, and they're all real. We didn't go to the imaginary world. But if we needed to, we would have eyes and stuff, and you guys should be able to do that. I believe. So once again, our 5 final answers are x equals 0, x equals positive square root of 5, x equals negative square root of 5, x equals 1, x equals 1, and x equals -1. If you plug it into the equation, you will get the right answer. So that's it. Have a good day.